Assalamu alaikum, my dear students. How are you? Hope all of you are well by the grace of Almighty Allah. Welcome to NIEVS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National Ideal English Version School, Basic. Today I am going to take a physics class for class 9 students. My dear students, our today's topic, Chapter 3, Discussion, Part 6, and our today's lecture number 20. So let's start our class. My dear students, this is Chapter 3, Force, and today we will discuss some short question answer from this chapter. This is important for your exam, and then we will solve mathematical problem. Okay, let's start our class. At first, this is an important question. The weight of any body is 0 at the center of the earth. Explain. The question is, the weight of any body is 0 at the center of the earth. Explain. The answer will be, since the gravitational acceleration is 0 at the center of the earth, so the weight of a body falls to 0 there. My dear students, I am repeating. Since the gravitational acceleration is 0 at the center of the earth, that means G is 0 at the center of the earth. That's why the weight of a body falls to 0 there. The force with which earth attracts an object toward itself is called its weight. My dear students, I am repeating, what is weight? The force with which earth attracts an object towards itself is called its weight. And if the mass of an object is multiplied with acceleration due to gravity, its weight is obtained. Since acceleration due to gravity is 0 at earth's surface, so its weight is 0 at the center of the earth. That means the answer will be the gravitational. Since the gravitational acceleration is 0 at the center of the earth's surface, then the weight will be 0. And what is weight? Weight means the force with which earth attracts an object towards itself is called its weight. Okay, now come to next question. Does the acceleration due to gravity depend on the mass of the body? My dear students, I am repeating the question. This question: does the acceleration due to gravity depend on the mass of the body? Answer will be, acceleration due to gravity does not depend on the mass of the body. That means G does not depend on the mass of the body. And from Newton's, this we can solve this problem from the Newton's laws of gravitation. Okay, my dear students, we know Newton's laws of gravitation is F equals to G mm divided by r square. My dear students, I am writing here. We know the Newton's laws of gravitation, F equals to G mm divided by r square. This is equation, suppose this is equation number 1. Then we know again F equals to mg. F equals to ma. From this formula we can write F equals to mg, and instead of a we can write g. This is acceleration due to gravity, and this is equation number 2. And from equation 1 and 2 we can write mg equals to G mm divided by r square. Okay, and here the capital M is the mass of the earth, small m is the mass of the body, r is the radius of the earth, and small g is the acceleration due to gravity, and capital G is universal gravitational constant. Okay, now we can write from this equation mm. So we can write as G equals to Gm divided by r square. Okay, and this is equation number 3. So see this equation, G equals to Gm divided by r square. Here m is missing, absent. That means mass of the body is absent. So therefore we can say from this equation, the acceleration due to gravity does not depend on the mass of the body. Okay, this is G means acceleration due to gravity. So from this equation we can write acceleration due to gravity does not depend on the mass of the body. Okay, so now come to next question. What is impulse force? What is impulse force? The product of force and time is defined as the impulse of force. My dear students, I am repeating. The product of force and time is defined as the impulse of force. And another question is, impulse of force is equal to the change of momentum. Explain. Answer will be from Newton's second law of motion. We know the Newton's second law of motion. F equals to mb minus mu divided by t. Okay, the rate of change of momentum is proportional to the applied force. Okay, this is the Newton's second laws of motion, and from Newton's second laws of motion we get F equals to mb minus mu divided by t, and we can express the change of momentum from this equation as we can write F into t equals to mb minus mu. This is the change of momentum. That means momentum means mass into velocity. So here m into b minus m into u, mb minus mu. This is the change of momentum. Okay, and from this equation we can write F into t equals to mb minus mu. That means the force, the product of force and time is equal to the change of momentum. We can express this change of momentum from this equation, F into t equals to mb minus mu. So now the product of force and time is defined as the impulse of the force, F into time. That means product of force and time is called impulse force, and impulse force is equal to the change of momentum. This is the change of momentum. So therefore impulse of force is equal to the change of momentum. This is proved. Okay, my dear students, now come to next question. Explain how we walk. In our daily life, we walk or run on the ground. When we walk on the ground, we exert a backward force on the ground, and this is action force. Okay, when we walk on the ground, we exert a backward force. We exert a backward force on the ground, and this is action force. According to Newton's third law, the ground also applies an equal and opposite force on our body, and this equal and opposite force creates the acceleration and we walk. My dear students, now come to mathematical problem. The question is, the height of the space station from the Earth's surface is approximately 100 km, and what is the value of g there? Okay, now we will solve this problem. At first, write given radius of the earth. In the question here given a radius of the earth equals to 6000 km. Okay, so write given here r radius of the earth. R is radius of the earth is here given 6000 km. Height of the space station here given. The height of the space station is r. Height of the space station r is given here 100 km. Okay, and in the space station the acceleration due to gravity is suppose g dash, and we know from the formula g equals to gm, acceleration due to gravity, g equals to gm divided by r square. Okay, this is this equation, g equals to gm divided by r square, and we can write suppose this is g is in the space station acceleration due to gravity, it will be g dash. So we can write gm divided by r plus r. This is the radius of the earth, and this is the height of the space station. Okay, so right from this formula we can write this formula, g dash equals to gm divided by r plus r whole square. Okay, and now gm divided by r into 1 plus small r divided by capital R. Okay, we can write this one. Then we can write gm divided by r square into 1 plus r by small r divided by capital R whole square. Okay, so And now gm divided by r square is g. We know this is g. So we can write g divided by 1 plus small r divided by capital R whole square. So now put this value g, the value of g is we know 9.8 meter per second square, and here 1 plus small r means 100 divided by capital R means 6000 whole square, and doing this calculation we will get 9.49 meter per second square, and this is the deceleration due to gravity. Here what is the value of g there? That means the value of g there 9.49 meter per second square. My dear students, I hope you have understood our today's topic. Memorize properly this short question answer. This is very important for exam, and solve the mathematical problem also. Okay, keep practicing at home. See you again in the next class. Allah Hafiz.